Hi, Slane. Kevin, how are you doing? Hi, Kevin. Okay, so it is 5. I'll go ahead and get started. If you want to log into Canvas and check out your lab for today, you will need your virtual machine, which is in Linux. We created that a while back, or you can make another one if you like. So before we start the lab, let me share screen here. I wanted to touch on, sorry, slow. There's some issues with, I guess, Jupyter. I'm receiving a couple emails regarding that. I think the important things, I added a couple of things. I know that I had wrote some of you back about Jupyter Notebook. You can actually make a working directory for it, and the instruction for that is located here. And in the case if you run into kernel error or other things, it is not that stable sometimes if you don't set things up properly. So there are some of the frequently asked questions, they posted that there. One of the things that I want to point out is for all the things that we are doing, you need to make sure that you're setting up your environment variables, your path. And if you don't have that set up, likely that you will run into a lot of issues with your packages because it cannot execute through Python when you're using the Python command. And if you have multiple versions of Python, the system is going to be confused. So you want to make sure that you have the appropriate versions. So here it walks you through on how to be able to do that, but you can do that in control panel, which is in a later step. And you wanted to add the user variable and the system variable. It walks you through on how to create those things. So
make sure that we take care of that, because you're going to run into issues with executing some of the program or building some of the program. Okay. And Jupyter Notebook, in the case where if you can't get it to work, make sure that you just write out your code, because even if you can't build it, I will give you credit for just writing your code, and that will be fine. Okay, so in the lab today, lab 5, we're gonna work on building Cython in Linux. It's a little bit better compared to what you've seen in Jupyter. So I want to introduce you to how to be able to establish this. You will need to have a virtual machine, and we previously used the Ubuntu. Just keep in mind that as you install a lot of different packages and the desktop take up a lot of space, it might have used up a lot of your storage already. So you can remove some of the packages that you don't need, and then be able to add in more, or you can just simply create another virtual machine. And it's really easy. I think I had walked most of you through the process, but you can definitely use the Ubuntu virtual machine. So I have a virtual machine. I'm using regular Ubuntu. The process isn't the same across. And so you want to be able to open up command line, okay, to start. And once you're in terminal, let me see if I can make something bigger. Once you're in your terminal, what you're going to do is you're going to make sure that you install Cython. So you're going to do a pip3 install Cython. Now, keep in mind that we already have the Python version that's installed. You can run an update on Ubuntu, or you want to make sure that you can install Python 3. I know that all the newer releases is shipped with Python 3, so you can always check. And the way that you can check is you just need to say Python and then version. And if you put Python 3 version, it's going to give you the 3, but you want to put regular Python version, so that way it wouldn't put the actual Python version that's linked to your environment variable in the Linux systems. So I have the 3.8.10 here. Then later on, you will also use NumPy, and if you haven't installed NumPy, you need to make sure that you install NumPy. So it will throw an error, okay? So now the next part, what we're going to do is we are going to put in the GNU-C, which is the compiler. So you want to install the build essential. So as you issue that, it's going to pull the packages after it asks you for your password. And as I already have installed it, it's going to tell me that it's already been installed. So I have the newest version for Ubuntu. Just make sure that we install that, because without it, you won't be able to build your program. Okay, so I wrote down the step, and we're currently at step 3. Then in the next part, sorry, I skipped number 5. I meant to add something there. We just want to make sure that we are linking everything back to home as you are going to write your program. And what it will do is when you write your program, if you look at your file manager, or you can use dir, you're going to have these file in .pyx. And when we create this file in .pyx, you can write in Python, C, or Cython. It doesn't matter the syntax that you're using in these files, but ultimately, when you build your program using the compiler, it's going to take your code and it's going to convert it to a C file or .c file, and then it's going to make an object file like this. So as you can see, even if it converts it to C file, if it runs across error, you're not going to have an object. And without an object, you won't be able to use Python to import in as a module. So what we're doing here is we're creating a module, and it is a Pyrex file because Cython uses Pyrex. And we're using a compiler to convert that to a C file, and then use that C file to make an object file, and then be able to run the object file or run the application, execute the program through the import command in Python shell. Now, why are we doing this, right? We talked about how it would be faster than your regular Python. It can be actually 100 times faster. It all depends on how you want it to be, compared to just having regular Python and run it through the Python shell. So that's what we're going to try to achieve today. And coming back to the terminal, after you have installed your Cython, after you have installed your build essential, then you can go ahead and get started with your script or your code. So we're going to do a nano to be able to access the Linux editor, and we are going to give it a name. Okay, and in your case, you are going to put hello.pyx because that's the Pyrex file, or the file that you're going to use to be able to convert to C, and your code is going to exist there. So I already create one. So what we're going to do is I'm going to make a hello1.pyx, and it's going to open up your text editor. Here, what you would do is you would start with writing, and we just wanted to test, so we can say print hello world, right? And this is simply in Python. Now, if you want to use Cython, then you would do an import for the printf, or print also works. Then you can you just write the statement, and then you're going to save. So right now I'm at step 6. Then after we have written our statement or our code, we're going to save it, and then we are going to create a setup file. And once you create the setup file, you can modify it or create other setup files out of it. In the older Python, if you're using Python 2, you have to put in different packages compared to Python 3. So you want to use setup tools, and you wanted to build it for Cython. So you want to import those in. Okay. So once I have this file, my code is created, hello.pyx. I'm going to hit Control X on my keyboard, and it's going to ask me if I wanted to save. I wanted to press Y for yes. And then I'm going to go ahead and press enter because that's the name I want to use. And you can always go back to that file by doing nano and then the file name. So once you have the code created, then you are going to create a file called setup.py. So again, we are going to use nano, which is our text editor, and we are going to create the script in Python that's going to be able to convert. It's going to take your hello.pyx and convert it into a .c. And then we're going to execute a command to build it into an object file. And then after that, we're going to use the object file to execute the program. Now, I know it's tedious and it's multiple steps, but if you want performance using Cython, you would see that this is going to give you much faster application. And so it does take a little bit of setup. Okay. So once I have the setup file, let me go down and change this name here. I'm going to put in the code for the setup. And it's really simple. What you're doing is you are going to bring in the setup tools. You are going to bring in Cython.build, and we're going to call it setup and Cythonize. And we want to tell it that in the setup, it's going to run an external module, which is Cython build. And it's going to apply that module to your hello.pys, which is your script that you wrote previously. So whatever your file name and extension would be, this is where you need to change. Okay, so now the setup will be the same across all your PYYX, except for a couple areas when we're using NumPy. You can also import in NumPy to it. So what it's going to do is going to take this file and it's going to create a .c file out of the one that you have written. Then after we have the setup file, then we are going to go ahead and click Control X on our keyboard. And then we are going to save it, press yes. And then we are going to use setup.py, the name. So that's what we have. And you can always go back to it by using nano command. And if you don't have nano install, you can do pip3 install nano or sudo app and apt-get install nano. Okay. So once I have number 8 accomplished, which is the setup.py file, then I'm going to run a command to be able to build my .c and my object file. Now, if it's successful, you're going to see that it's going to give you what I showed you before, this file. Okay. But if it's not, it's might be able to still create a .c file. But if you don't see an object file, that means that it's not able to execute your program. And it will throw an error when you get into the shell. Okay. Cython as a package, it does not have its own IDE or shell. So you piggyback on Python shell along with the compiler, the C compiler, to be able to build your program. Now down the line that might change, I don't know, right? So right now this is what we have. And in the case where if you create modules, right? So the way the system treated is that we're going to treat it individual file as module. But if you're creating a module or a library and you wanted to use that in other modules, and the book called that sharing declaration, then you have to name your file .pdx, and then you have to modify your code to be able to make sure that the modules, they see one another. Any question? Okay, so once we have the setup file, we're going to execute the command. We are going to tell Python to run the setup.py, which is the script that we created. And it's going to take Cython package and it's going to apply that to the files that we wrote. Okay, and you simply, every time that you modify your code, you have to rebuild, right? And this it's like just regular C++ or Java, right? Anytime that you modify your code, you have to rebuild. And if it's built successfully, it'll tell you, okay? And you would also see the object file like I told you. So in after we have our our setup file. Let me minimize this a little bit and pull it over here so I can see both of this and follow along with you. Then what we want to do is we want to put in Python 3, and we're going to run the setup.py. So whatever name that you give it, you have to use that name. And then we are going to do a build _ext and make sure that space is important right there, because if you have no space, it's going to throw an error. Then you're going to hit -- in place. Okay. And it's going to take a second for it to go. So once you have that, you're going to see that it is running the build. Okay. And it doesn't throw any kind of error. What it's doing is it's creating, see, hello Cython or C Python. And that's what you have. So now we can also check out our file. You should have this in place after you built it. Okay. At this point, what we can do is we can execute it now. Okay. And the way that we execute it, we are going to call up Python 3. And now you're in shell, as you see the arrow. Then once you're in Python 3, you are going to import in your module name, which is the hello, right? You convert the PAYX to the .c, or you create the .c and the object. So now when you do an import hello, you should, in the shell, you should see whatever the content that you have it printed out from your script, your code. So we are successful here. Now in the documentation, it talks about Python is, let's say that we write the script and it's only 10 lines, right? And we save it as a .pyx and we create the setup file. In the process of creating the C file, what happens is it's going to take that 10 line of script and convert it into thousands of lines, because then it has to run it through the compiler to be able to create your object. So is this completely efficient, right? Now, as far as the program performance, yes, it's going to be faster. But as you can see, the process in this is a little bit more lengthy than just writing Python program. Python on its own is fine, okay? But if you're looking at a more resource intensive program, Python on its own might not be the best. So we wanted to know other options. And do you necessarily have to use this in the industry? Not necessarily, but if you want a little bit more in the performance, this is another option for you to use. And so that's why we're covering it. Okay, so the process is always going to be, we want to make sure the package is installed. We want to make sure that our path is set up to be able to execute that package in Python, no matter what environment you're using. Then you are going to create, right, a .pyx or a pyrex file, which is used for Cython. Then you're going to create a setup file. Then you're going to issue the command to run the setup file to build your .c and your object file. Then you're going to access the shell and run the import command to bring in the module that you created that was built. and there you would have your running application. Now, when you're using Jupyter through IPython, you would see that it's always going to be using the kernel, and it's going to load certain things, it's going to execute it, and it's always going to be running unless you stop it from running. So in Jupyter, when you run a Cython code and it builds it and it shows you the output, when you close it, it doesn't necessarily mean that it releases the resources. So you want to make sure that you end the process by stopping the kernel, or hit stop at the top, and then that way you would release the resources for your system. Okay. Any question? So I want to do the very basic to start, so that way you can understand what the processes might be. And then when you create more complex program, it's the same process. Now on the Windows side, we talk about using Visual Studio, and then you just build it through Visual Studio, and it will put it into your source code folder. And you just got to bring in the packages and the tools that you need for Visual Studio. So you're using an application to really organize all of these components, so that way the process can be streamlined through that application, which is your IDE. Okay. Question. All right. So now we're going to try to accomplish number 12, as we already had 11 steps on how to really go through to do a basic program. We're going to do the number 12. So we are going to create a module, and in our module, we're going to have two variables. We're going to assign variable 1, 100. We're going to assign variable 2 as twice as the value. So we want to use the operator there. And then we want to cast the type from integer to double. Okay. And then, I'm sorry, var2 is going to be double, and we're going to cast it into integer. After we write our code, then we are going to create your setup file again. So if you're using the last one, all you have to do is to modify the name of your Pyrex file, of your Cython file. And then you're going to build it, you're going to run it, and you're going to give me a screen capture. Okay, so I have an example. So I'm going to go ahead and exit my shell by using the exit function. I'm back to command line. And I would start with doing a nano. Let me double check. I think that's how I name it. Oh, I think I call it double. Oh, no, it is var. Okay. So I have I'm going to create a file called var.pyx. And I'm going to use Cython in this one. So here what I have is on the first line, I have a definition for a variable, and C, you have to make sure that you type it. So in your .pyx file, you can use C syntax, you can use C++ syntax, you can use Python syntax, and you can use Cython syntax. Because it uses C compiler, you have the option to do that. In Cython, it works with C or Python, and C++ is built on C, so it should be fine, because you have to bring in the build tools for C++, including when you do this. Okay. So the first line, I have the definition for my variable 1, and I assign it 100, like the assignment asks. And I want to print it, and you don't have to print it there. Then I have another definition for, I declare the second variable, which is going to be type double. And once I declare it, I can operate the double because it is twice as variable 1. So the assignment of variable 2 is going to be 2 times variable 1. And then since it is a double, I'm going to cast it back into an integer by reassigning the type. And then I do a print so I can see the output. Okay. And in this one, we see that we are using Cython because Cython uses cdef. So whenever you define a function or a function, a variable, a class, you can use cdef. In a function, you can also use cpdef. Or a class, you can also use cpdef. Okay, so once I have my pyx file, then I'm going to hit Control X to save. Sorry, let me go back to it. And it should ask me, do I want to save or not? And I would say yes. And I want to make sure that I have the proper name. Sorry, I'm in my office. Then once I have the pyx file and save it, hit Control X and then press Y and then press Enter. Then I am going to create a setup file. So you can go back to your setup file, right? What I did was I created different setup files. So in case I troubleshoot, I don't have to go back and modify it each time. So I have a different setup file there. So I call that setup1.py. And the only changes between the last one and this one is just your file name and extension there. So in our setup file, just like before, we want to bring in setup tools, and we want to bring in Cython build as an external module. We're going to apply that module to our code that we wrote, which is, in my case, var.pyx. Then once I have my setup file written in Nano, I just hit save, right Control X, Y for yes, and then press enter to use the name that I gave it. And in my case, I'm using setup 1. So just like before, as you recall, when you see this in command line, after I have my setup file, my next step would be to build it. So I simply go back to that command, and I just need to change up my setup file name. In my case, I have setup 1. Oops. And then I'm going to go ahead and build it. And when you build it successfully, you will not have a bunch of messages that will be error. It will just be like 1-2 lines, and it's going to say that it's running the build, and it's giving you the var.c, and also create an object called var Python 38x8664. And you can visually see this in your file manager. Okay, Now, in the case where if it built the object file and everything goes smoothly, and when you execute it, you're not getting what you want, then it is because your PYX file is not appropriate written. So then you would go and modify it, rerun the build again by using the command, and then you can execute it. So every time that you modify your code, you have to rebuild. Okay. Any question? So once we build this, what we can do is we can then go into Python and then we just import it, import var. And so I would see that my first variable is 100 and my second variable is 200. Any question? So in my opinion, Linux is much more friendly with Cython in the use of it. And it responds better as far as, you know, be able to build and even on the more complex. And plus, you're able to run different Linux command to be able to measure the performance and build the profile for it. So just for practice, I think it's good that you know how to use Linux tools because this is well used in the industry. And everything you can achieve in command line, right? So we're not really using multiple applications to be able to bring things in like what we've seen with Jupyter or VS Community. And can you achieve that with Windows environment? Yes, I think you have to run the script to actually run a command to get your C compiler in and all the C++ packages, and then you will be able to build it. And the process would be similar to this, where you would have a .pyx, and then you would have a setup file, and then you would execute after you build it. But you have to get the compiler into Windows environment before you could achieve the execution of your program. Any question? You can use Mac OS. It would be the same process in that. I had a problem last Monday, Jupyter Notebook, I typed print and it would not print the address of the variable CDEF-AA. Okay, but did you declare the variable? Okay, I'll come back to this at the end. If you miss a line on, because if you have to declare it as a pointer and then you can reference it. Yep, I know it was short. Yeah, I have it on my directory, so my working directory. I'll come back to it. I think it was one of the assignment questions, right? Okay. So the stuff that you did for the assignment, right? You can test it in here. You can test it in Linux. You can make the .pyx and then you just run the setup and then you build it and then you import it into Python. And if it outputs, then you have everything correct. If it throws error, then you check a few things. First, you got to read the error to see where that is. If it's missing files or modules or things like that, then you want to make sure that you add the module. But if your code is wrong, likely that's the case, then you just go in and edit your .pyx, rebuild it, and then execute it. Okay? So you can the only difference between Jupyter and this is that Jupyter uses IPython and you're using all the magic command. And if your packages are not linked to your working directory, your magic command sometimes gets forgotten because it's temporarily putting it into cache and it's not able to remember that over time. So when you pause it or when you close it or reopen it, even if you reload your Cython, IPython doesn't remember its magic command when, you know, and because it cached it or it got written over, then you have to, you know, re-establish the process. But the issues in Jupyter also is if your kernel is paused or if your kernel is, you know, if there might be some error in the kernel when it's loading certain things, then you have to go and fix that. So Jupyter has a lot of various issues. I know Google has a similar notebook that I know that the UC, they also use that. But when in the server environment, they had set up everything and they linked everything properly. So their students just need to log in and be able to do the lab. And so it would be graded. So in that case, it would be more managed compared to if you're setting it up at home. Yeah, so if your printf is not giving you, so when you're using the percentage symbol with the P, all that is it's a format to give you the pointer. Okay, so in C, when you're using the percentage symbol with the P, that's formatted for a pointer, which is gonna, and then what you're doing with the ampersand A is that you're gonna reference that address of A. Okay. Now, yeah, I'll check this. I'll open mine up later on and see. So Michelle, did it give you anything or did it throw an error on that program that you put in the chat? It says for the end of class, this is what not print address. Okay. It's just blank. Okay. So that means that it's not able to find your pointer, right? It's not able to output the print because either that or it's not able to take the address and convert it and give you the print. I ran into problem with printf inside Linux actually, because for some reason it's not able to see the libc studio, even though I had installed it. So, yep, you have to use the build tools. Let me see if I can find the link for you here. Oh, she did put it in there. Thanks, Michelle. Okay, so Michelle dropped the information for the build tools in there. Okay, next one. We're going to talk about the next program. Number 13 and number 13 or 14 on yours. I think I changed the number on mine. So we are going to use Cython to create the to calculate, sorry. I don't know why. To calculate the sum of all elements in the array. And in this one, you want to use NumPy. Let's see. Let me put it on my download so I can take a look at the image that you sent. Okay. So on here, it tells you that I actually put this, I clipped this on from my Linux editor, my text editor. So this is the program. So you are going to import time, and you can say from time, import time, or you can just do import time. You are going to also import NumPy. And if your Linux virtual machine doesn't have NumPy, then you have to install NumPy. pip3 install NumPy. Okay. So make sure that we install NumPy. Now, what we're doing is we're using the time module to really give us the time that it takes to execute our loop. And we're using NumPy to access the attribute arrange so that way we can create our array. And there are many ways to make array. You can make an array using array method. You can make an array using array ND. And the array ND, what that does is it's giving you the number of dimension that you have to specify in the argument. Okay. And then you can go to NumPy documentation. You can look at different methods that you can use. So what on the next line here, what we'll have is we're going to have T1 is going to be time.time. So we are going to use T1 to store the time. And then we want to measure the amount of time that's going to take for our application to run. So then in the next loop, that's going to be your for loop. And we are going to use for to be able to access each of the element and then add them up. So you can do total plus equal total plus k. That's the same. And then next we are going to use T2. And T2 is going to measure the time. We're going to print, and then we're going to find the difference. So we are going to format, and the way that we're formatting this is just going to be for the decimal point. And we're going to output the time. Okay. Now, if you wanted to know how to use the time module, you can look at this here. And then it talks about how you can use different functions with time to look at your clock or get time and so on. Okay. Okay. So I have a file called L5 EX14B. Or maybe not. Let me check. I named it. It would help if I put the extension. Okay, so to start, if you didn't catch that, is we are going to make a file, and you can name your file anything you want. So in my case, I put lab5 ex14b.pyx, and then I add the code. Now this is pure Python. So we're not using anything that is Cython or C here. And then you can also convert this into Cython by doing the cdef, right? For your variables. And then that way you can see the time difference. But we will start with the Python, and then you can play with it and change it into Cython and see how it is different. Then once we have the code, and the code simply is just going to give us a running sum, and we're going to measure time throughout. Then we are going to save. Then we are going to create a setup file. What was it? EX L5 EX 14b.py. I don't remember what I called it. Oh, I just called it 14b. Okay. And just like all the other setup file, you would have the top, which is the setup tools, the Cython build, but I had to add this because as it goes through and it apply the build to your file, as when it converts it to C, it loses the numpy directory. So it's gonna throw an error where it could not link. You can fix it through linking it where you would, export the directory, but just to minimize the problem, you can just add in import numpy. And then you would have your setup. So this setup file is slightly different than the other one in that we would add in numpy for the import statement. And then we would just change up our file name. And then we would save. So once I have my setup file and my code, I simply execute the build. However, my setup file is name. Now here, if it's giving you any kind of error, make sure that you go back and check where that error would be, whether it's in your code, in the .pyx, or in the setup file. Okay. then after I have built my program, then what I would do is I would call up Python, and then I would just import in L5EX14B. And it tells me that my total is this, and my time is this. Now, if I run it again, right, it's already in there, so it's not going to execute it again. So I have to exit Python and then get back in. Any question? Okay, no question, huh? Okay. And the only difference between part A and part B is that part B, you are going to do 2 modules. Actually, you're going to have 3 programs. Okay. You're going to have one that's pure Python. Then you're going to have the second one is going to be Cython. Then you are going to, of course, create your setup file and build those. Then you are going to create a third file, which is a Python file that you are going to import in the other ones and test them. So you can check to see which one is faster. Okay. So on the first one, we would do a Python test.pyx. I'm sorry, .py. And then we are going to write our Python. So we would say def test of x is y equal. Then our for loop. And we're going to return y. So in the for loop, we are going to have the increment in the range, and then y is going to be y times the index as it loops through. Then we can save. And then I want to say yes, and we're going to say python.py. Then we are going to write the Cython pyx. So we say nano python oh, sorry, Cython test.pyx. And in that, just a few lines, we're going to do a cpdef int test int x. So here we define a function called test. And then inside this function, we're going to define the variable. Y is going to be 1, and it holds integer. That's the type for Y. Then another variable called I for our for loop. And then we are going to create a for loop, I in range. And the same thing as the other one, code is almost the same, except that we're using Cython syntax. Then our Y is going to be Y times I. And we are going to return Y. Then once we have our Cython code, we are going to save. Sorry, I'm not seeing everything there. Yes. Enter. Then we are going to make our setup file. So go to our old setup. I'm going to go to my first one, .py, and then I'm going to edit my file. And that would be Cython test. And we're going to save. I'm going to call this setup test.py. Yes, different name. Then we are going to execute the command. And I just need to change up my setup. Test.py. So I'm getting a security error. That's a module, so test extension. Yeah, it built it, but it just gives me the warning. I think you can suppress those. And then lastly, I just need to create the Py file to run the time profile on this. Okay. So you already saw the process on how that can be done. We just need to, so if you want to measure the difference in the performance of two programs, you can use the timeit command in Linux. But in the timeit command, you only can execute a certain statement, okay? If you want to measure multiple programs at the same time, then you can write the script. But first, in our case, since we're using Cython, first you have to build the program, or and then also build the module in Python, and then measure Cython against Python. Okay. So in this script, you simply, after you created those, you just import them in, you import the time like the last one, and then you want to check the start and the end time, which gives us the total time that it's going to run the Python, the pure Python, um, the pure Python file. And test here is a method that is built in with our module. And then for this part, we are gonna find the time because it's gonna log, it's gonna put the timestamp on the start and the timestamp on the end. And when we subtract it, we actually have the amount of time that it takes to run that program, that script. Then we do the same thing for Cython tests. And then we are gonna look at the timestamp for the start and the end, and then we find the difference. And then you just need to put it into the format so that way you can read it. And then if you want to look at the percentage or the ratio, then you can print that out. So that's what that third program does. And when you execute it, you just go into Python 3, the shell, and then you call that file, or you can run it through the command line using Python. Python 3-m testcode.py. And you have it. So what I wanted to achieve with this lab is to show you how you can build Cython code, right, in Linux, the process in that. And with that, we can also look at the difference in programming languages, how C compiler handles certain type of library with a certain programming language. And we can measure the performance or compare the performance from one to the other. In the case of our last exercise here, our algorithm is the same, right? We only have a for loop to be able to operate the arithmetic there for both sides. And you would see that Cython is faster. Okay. And once you get a hang of it, it doesn't take very long to really build the Cython code. The initial part is just to get your setup file and then be able to build it. And if you run into like syntax problem or library problem, then you just have to fix it. But other than that, you know, everything is generally pretty straightforward and short. Now, I put everything into my home directory because that's where I installed my packages and things. But you can definitely, set up, ideally you would set up a working directory like a folder, and then you can cd into that folder and then be able to manage it there. So you have your source code there and be able to run your application. But, as for the convenience and just to keep it simple for you guys, everything I have under home. Okay. All right. Any questions as far as lab 5? So not as challenging as your assignment. Okay. Let's take a look at Michelle's question from earlier. And thank you, Michelle, for sharing the fix it on this util platform error. Let me find my Jupyter. And just side note, I sent your resume over to the apprenticeship people. So they'll reach out to you soon. Let me find the program that we, okay, I'm gonna stop recording here because it's just gonna be